Okay, hello and happy Friday. It's a happy, I guess, week 5 Friday. So we are about halfway through our quarter, which I've got mixed feelings about that. I just was mentioning to the other class, January felt like such a long month, but it also at the same time it doesn't feel like we've been in school for that long, or I don't know, maybe it feels that way. It feels like, oh man, we're already halfway through. It's kind of crazy. Anyway, on Canvas, I posted a practice or I guess like old midterm exam. Okay, and so this is for you as a kind of a resource. I don't normally post practice midterms. Normally, what I do is I just give a description of the exam. So like for the final, I'm not going to give a practice. It'll just be like, this is a description of the final exam. And, in future, if you ever take future courses with me, I just give a description of the exam. But basically, here is, I've got kind of a list of the lectures from which I will be, asking questions based on this content, and so basically lecture from our first lecture of content, so basic data structures, to Wednesday's lecture this week, which covered R6 object-oriented programming. The midterm exam will cover that stuff, so it won't cover today's stuff, which is I'm going to look at ggplot 2, and it won't cover the content I cover on Monday and things like that. And notably, it's lecture 3.2, which covers importing, exporting, RVest, and web scraping and that stuff. That will not be on the midterm exam. So notably, that will not be covered on the midterm exam. But pretty much everything else you can kind of expect to see. For regular expressions, I will include this PDF, this cheat sheet PDF. I'll print that out and include that as part of the exam. And then, and I told the other class, and I'll tell you guys, I will allow for one cheat sheet, and I'll mention that in the on Canvas as well. You can have one sheet of kind of notes, and I guess you can kind of put in like these small trivial details and things like that. This is a practice exam. It's for your use and for your aid and study. It is, I don't want you guys to share this file. I don't want you to post it on Chegg or someplace like that, okay? Course Hero. So don't do that. But you are allowed to ask questions about problems from this thing on CampusWire, okay? Or really any other content from lecture you can ask on CampusWire. So on CampusWire, you can say, here's a question, here's this problem, and when I type this into R, what it outputs is this, and I'm not quite sure if I understand why, right? So pretty much the exam is going to look kind of like this. I've got some code, and I'm going to ask, what is R going to output? What is R going to output in all of these things? And that's pretty much the entirety of the exam, okay? You're going to just see some code, and I'm going to just say, hey, if you do this, what's R going to output? And I want to know if R is going to give you an error, or if it's going to give you a warning, or it's going to do something else, okay? And that's what you're going to do, okay? The one question I don't want you to ask on CampusWire is, do we need to know topic this for the midterm exam, or do we need to know how to do this on the midterm exam? Okay, I'm not going to answer those questions, and certainly your classmates aren't going to know the answer either. So don't bother asking those types of questions. Okay, this is as much as I'm going to tell you about the exam, and of course you're not going to see these exact same problems on the midterm, right? But it's going to kind of be similar in nature, in that I'll have here's some code, and what is R going to output, and it'll be like little some of these things will be a little bit weird, and you might feel like, man, why are you testing on us on all this weird stuff and this trivial stuff? But that's usually where you run into problems as far as debugging your code and trying to figure out what's going on and why is it not working the way it's working, is probably because somewhere along the way, you or someone you're working with wrote something a little bit weird in your code, and now it's not doing what you want it to do. And so being able to read and understand even like the weird things, right? Being able to read code that is not perfect is going to be an important skill, right? When we teach you, we always try to show you like good quality code, and good quality code is made so it's like you can read it and it's like clear and it makes sense to you, right? But sometimes it's like you have to read like a legal document and it's like, what? And it takes you like 10 times reading over the same sentence to figure out what exactly do they mean and stuff like that. And that's also an important skill. And so sometimes you're going to see this and you got to know like, oh, okay, this is going to return a list object, or this is going to return a vector, or this and that. And so that's what the midterm exam is going to test. And for those of you who are, I think only a couple of students are going to take the exam remotely, but the remote exam is entirely different in nature. And that's, I can't, there's nothing I can do really about that. It's just, when you're taking it at home, I can't stop you from like opening R on a separate laptop or something hidden from view. And so asking these questions would be completely not a valid way of testing your knowledge and understanding. I think most of you, I got a lot of responses on kind of the survey on whether you're available during the day or the evening, because the goal is to reduce the classroom density. There's like 80 students enrolled, and if we were to shove 80 students in this classroom, it'll be, very densely packed, which, maybe at some point in the future that will be okay. But, right now, I think some students are hesitant about that. So right now we'll do density reduction. And so I asked if you're available in the day or the evening, and I think most of you responded. A few of you have not. So if you don't respond, I'm going to assume you're available at both times. But so make sure you let me know. Okay. Any other questions? Any questions about the exam? Okay. All right. So we'll let me shrink this down. And we'll take a look at today's topic, which covers ggplot. ggplot, all right? ggplot is one of these topics where some of you already have a lot of familiarity with ggplot. You've had a lot of experience with it, and you're very comfortable working with this. Others of you, maybe you've seen a little bit of ggplot, and but you're not super well versed in it, and this lecture is mostly for the people who aren't well versed in it. Okay, if you're already super comfortable with ggplot, please just bear with me as we go over this. But hopefully, it still will be a useful lecture to go over. The content in the lecture comes. A lot of it comes from this textbook, rgraphics.org, which is available for you to read for free in your browser. You just go to rgraphics.org, and that's great. Of course, if you want the paper version, you have to pay for that. But I think a lot of you are fine with just reading in your browser, and I'm very grateful for there's kind of a trend for a lot of a lot of authors to make their work freely available. So like Hadley Wickham's textbooks are available for free in the browser and things like that. One note is, so most of the stuff I've chosen for like reading material, I've tried to find freely available resources for most of the stuff in most of my classes, with the exception of 102B next quarter. I do have a textbook, and that one's not freely available. You have to buy it. So that's the only one. But I think for 102A, I got everything is free resources. 102C is everything's free resources, and 21 everything again free resources. Well, I guess resources that are freely available to students enrolled at UCLA. So not available to the general public, but this one's available to the general public. But a lot of the other ones, it's like as long as you're connected to the VPN, you can get it for free. Except for next quarter, 102B. So I will be teaching 102B next quarter, but I just have one lecture. I got 80 students, 80 slots for that. And so if you want to take it, you got to hope for a good enrollment time, and you got to use your first pass. It does fill up quickly. So, but I got one lecture of it. But I don't know. I like the class. I hope you guys get in and you can take it. So. All right, let's talk ggplot. The GG in ggplot stands for Grammar of Graphics, okay? And this was a system created by this person, Leland Wilkinson. And he thought about what exactly is happening when we create a graph, right? So a lot of you have been kind of creating graphs, and since, I don't know, maybe 4th or 5th grade, you had to kind of create your first scatter plot or something like that. You know, they call them coordinate pairs or something. That's what they called it when I was in school, and you kind of created graphs and stuff like that. You know, ggplot. Leland Wilkinson thought about like what exactly is happening when we're going from the data to the graph, and the graph to our mind, and things like that. And he kind of recognized what the mechanics of what's happening here. And so we'll talk about that system. I'm a big fan of ggplot, okay? I'm a big fan of the tidyverse. I don't hide that at all. But I also want to say I still use base graphics a lot, and I think base graphics are great for a lot of things. For like a quick plot and a quick thing, base graphics is great. You need to kind of create a quick density plot, something like that, a quick histogram. Base graphics will get the job done. But if you want to create something a little bit more in-depth, a little bit you know, beyond what the most kind of basic cases are, then I think ggplot is very good, very powerful, allows you to create, you know, slightly more rich and complex graphics. I'm assuming you guys are already familiar with base graphics from Stats 20 or your other classes, so we're not going to bother with that. Okay, so let's think about, so what is happening when we create a graph? What we are doing is we are mapping properties of the data, which would be something like, you know, each column, properties of your data are stored in the different columns. Those are the different variables, okay? And we are mapping them to visual properties of the graphic, okay? So, for example, in a column, you might have numeric values, and you're going to map it to the x-axis or the y-axis, okay? And just this concept of me doing this with my hands and the x-axis, okay? There's already a visual conversion, or a conversion from one imaginary abstract space, right? So if you think about the real number line, okay, it's what is that, right? So what is a number, right? A number is this kind of this abstract representation of a quantity. You know, 2 represents this quantity of 2 things, and 7 represents a different quantity. And from an early stage, we kind of had you use a number line. And so already you have this kind of this visual representation of the real number line, which kind of corresponds to kind of like almost like physical distances. And we can recognize and understand these quantities and differences between quantities as actual distances in space and things like that. But that we're mapping from kind of this abstract numeric quantity into kind of this physical space. And we're accustomed to doing that to the x-axis, we're accustomed to doing it to the y-axis. But that numeric quantity, or the kind of the attributes in the data space, can also be mapped to other visual attributes, okay? such as the color of the points, or the symbol or the shape of the points, and so on. And it seems a little bit strange, but we'll see examples of this, okay? And basically, that's what a data visualization does. If it doesn't map from the data space to the visual space, it's not a data visualization. It's just a picture. So, for example, here is just a very simple imaginary data set, okay? I've got 6 people, 6 fictional people, okay? And we said here are their heights, their weights, their gender, their hair color, okay? And so, person 1, 62 inches tall, 120 pounds, female, gender, hair color, brown. And what we're going to do is we're going to map the different columns, the different data attributes. So here I've got height, and here I'm going to say, take the height variable and map it to the x-axis, and take the weight variable and map it to the y-axis. That's what I'm doing here. Height goes to x, weight goes to y. And then we're going to say, take gender and map it to, map it to the color. And take hair, this categorical variable, and map it to the shape, okay? And so in our data set, when we do this, this is the resulting data visualization, okay? So this first person with a height of 62, a weight of 120, female, gender, brown hair, shows up right here, okay? Height 62, weight 120, gender female being red, shows up here, and hair color brown, okay? So in our data, at least in this data set with these 6 people, we have 2 genders represented, female and male. And so we have 2 colors here, okay? We have red and blue. If we had another data set, perhaps with a non-binary person, we would have a 3rd color here, okay? In our data set, we have 3 hair colors: brown hair, black hair, blonde hair. And so, and we said map this to the shape. So we have 3 shapes represented. Okay, we have circles for black hair, triangles for blonde hair, squares for brown hair. And again, if we had another data set with more people, with more hair colors, say gray hair, red hair, purple hair, or something like that, we would have different, more shapes represented there. Okay. And so those attributes those properties of the data got mapped to a visual representation. And so that's what's going on here, okay? And the great power of a data visualization is that we are able to use our brain's ability to process visual information rather than having to think about quantities, okay? Our brains and our eyes are very good at just seeing patterns, right? You look up at the night sky, well, not in Los Angeles, but you go out to the desert and you look at the night sky and you see all of these stars, and I don't know if you've ever had that experience, right? So if you haven't, go one day to Joshua Tree or something, okay? Go out to the desert, look at the sky. It's absolutely amazing, okay? On a clear night, okay? So look at the stars. You look at that, you can see, your brains pick out patterns in the stars, right? You look at the clouds and you identify things. You're driving along the highway, passing a farm, and you just start seeing like rows and shapes and stuff in the crops and things, okay? Our brains are very good at that. Versus, and so when we look at this, we can kind of already see this, positive correlation, positive trend. We can see height in general. People with lower height tend to have lower weight. People with higher height tend to have higher weight, kind of represented in this data. Whereas versus looking over at this table, that relationship is not completely obvious. And if you think about it, it's rather remarkable that we can even look at this table and get information out of it. Because if you think about what your brain has to do this, it's amazing, right? You look at this, and this is basically just a squiggle shape, right? It's a squiggle, And yet our brain has now associated this squiggle with this abstract quantity of a number, 62, which again exists in this abstract numeric space, right? And we look at this squiggle and we say, oh, okay, this represents the letter F, and we say F represents, like we're looking at this, right? And we can go from, just these squiggles on the paper here or the screen here and turn that into a number, and we can kind of figure out some kind of relationship. But again, the extra processing of having to look at numbers and think of this in our head is not that finding the relationships between columns of numbers is not readily apparent versus just turning them into dots on a plane, and then we can say, oh, there's a positive correlation, or there's a non-linear trend, there's a linear trend, right? It's hard to look at numbers alone and identify whether a trend is linear or not, where when you turn them into plots, you can identify that very quickly. Okay, and so that's what's happening in a data visualization, is we're utilizing our brain's power to process visual information. And so if you think about what is the purpose of a data visualization, we've got to map properties from the data to the graphic. But equally important is that we have to make our graphic in such a way that the person who looks at the graphic is able to recreate the data in their brain. Okay? And if we look at this scatter plot, we could do that. We can go through every point and recreate the exact data set. We can look at this point and say, oh, and on my slides there's actual lines, but the projector, you lose the tick marks in the lines. So we can look at this point in the corner and say, oh, okay, this person has a weight of 120. This person's height is 62. This person has brown hair. This person is female. This person right here has a weight of 160. This person has a height of 65. This person has blonde hair. This person is female. Okay? And we can recreate, we can go through every point in this data set, and we can recreate the full data frame from the data visualization. Okay? Now, that's only possible because we provide what's known as a guide. Okay? So these are kind of the attributes or the properties of a graphic, and we provide a guide. A guide allows us to go from the visual properties back to the data space, allows the viewer to do that. A guide would be something like labels along the horizontal axis or the vertical axis. If I had removed this, then we would not be able to recreate the data, right? If I removed the numbers along the horizontal axis, or if I removed this legend, we would have a picture, but we would not be able to recreate the data set. Let me go ahead and give you your first view quiz answer. The first view quiz answer for our data, for today's lecture is B. B as in bear. B as in bear is our first view quiz answer for today. So some other things that we need to talk about, just these are the terminology that we use when we're talking about the grammar of graphics, okay? The data is just what we want to visualize. It's got to be tidy data, so it's got to have variables, and the variables have to be in columns, okay? The geoms are our geometric objects, all right? And so here, our geometric objects are basically points in different shapes, but they're points, okay? And you've got different geometric objects. You can have lines, you can have bars. Those are probably your most common things that we use, but there's other things, points, lines, bars. The aesthetic attributes are the visual properties of the geometric objects, such as where are we putting the point in the X position or in the Y position, or its color or its shape or something like that. We map is how we are going to map from the data attributes, the data values, to the visual attributes. Scales control how we map from the data space to the aesthetic space. So that controls how we do that mapping, and then the guides are there again to allow the viewer, once we've created the graphic, the goal is to allow the viewer to recreate the data in in their mind, okay, or on paper if they need to, but that's what we need. Okay, so let's take a look at this example again. We mapped height to the x, weight to the y, gender to color, and hair to shape. Okay. A nice thing about ggplot is that it creates the scales and the guides for us automatically. So ggplot looks at the data and it says, okay, this is where I should put the lower left corner. This is where I should put the upper right corner. This is how many colors I need to use. This is how many shapes I need to use based on the data. It creates a legend for the guide. It creates tick marks, labels the axes for us. It does all of this kind of automatically for us. So so this is kind of our visualization right now. We've got height to the x, weight to the y, hair color to shape, gender to the color of the dots. Okay. Now, what would happen if I switch? I'm going to say hair color goes to the color of the point, and gender goes to the shape of the point. What's going to happen there? So in my current data set, I have 3 hair colors represented. So I'm going to have 3 different colors of points represented in the next graph. Okay. In my current data set, I have 2 genders represented. And so in the next plot, we will have 2 shapes appear. Okay. And so this is what we see. We see red for black hair color, green for blonde hair color, and blue for brown hair color. And then we have circles and triangles for female and male. And again, if we had a different data set with more genders or more hair colors, that would appear in our data visualization as well. So this plot and this plot represent the exact same data, and from either of these plots, we could recreate the entire data set as well. Okay, so if I said, here's a plot, recreate the entire data frame, you could do it, right? But when we look at this and we look at this, our eyes are just drawn a little bit more quickly, I think, to the color of the dots versus the shape of the dots. Our eyes will notice the shape of the dots kind of like much later, right? Could you imagine if stop signs were not colored red and like you could only pick out stop signs based on their shape? I think it'd be a lot a lot easier to miss them and things like that, right? So our eyes will notice color generally before they notice the shape of the points. And so if you have multiple categorical variables that you want to represent, generally you would put the more important one to the color and the less important one to the shape. Okay. What if I tried to do this? What if I took hair color and I mapped it to the y-axis? Could I do that? So right now our hair color, we have 3 hair colors. It's a categorical variable. I have blonde hair, black hair, brown hair. Okay. Could I put that on the y-axis somehow? And instead I'm going to take weight, which is a numeric variable. What if I put that and I say I'm going to map that to the color attribute? Could that be done? Okay. Well, it can be done, and this is what the resulting plot would look like. Okay. So here we kind of just arbitrarily picked an order. Okay, black hair, blonde hair, and brown hair. So this is the arbitrary order of alphabetical order, which also is arbitrary, by the way. There's no reason why the alphabet should be in the order that it is, but we've all been taught it and we've accepted this as the thing that exists, but there's no logical reason why the letter B comes before the letter C, as far as I know. Okay, but anyway, here it is. We said, all right, we're going to put black hair color in this position Y. So anything that appears here will represent people with black hair. People with blonde hair will get represented in this Y position. Anything in this Y position will be people with blonde hair. people with brown hair will be in this Y position. Okay, so we have successfully mapped the categorical variable hair color to a position in the Y-axis. Weight gets mapped to the color attribute, color of the dot. And so weight is a numeric variable, a continuous variable. And so what we said was, well, the smallest weight we saw was 120, and that's going to get represented. It's supposed to be a very, very, very dark blue. And, on the projector, it looks almost black. And the highest weight, I don't know what number it is, but that's going to get represented with kind of the brightest color blue, right? And so, yes, the data is successfully mapped onto here, all right? And so we see here's a person with brown hair, a height of 62, female gender, and, well, the weight, it seems to be the darkest color point, so the weight's around 120. Now, if I said go from this visualization back to the data, recreate the data frame, you could do it, although your weight numbers might not be as accurate, right? Because it's really hard to tell, like, which point is darker here between these two, and I don't know, maybe they're the same, maybe they're different, I don't know, right? So getting the exact weight value, we can say, okay, well, this is going to be the highest weight value, but it's hard to tell. The ones in here, it's hard to tell exactly what weight they are, but we could kind of still do it. The same data is represented here. It's just a little bit strange, right? So when you look at this, ggplot does its best with the mappings that we tell it to use. And if you think about it, representing a number with a y coordinate might seem different from representing the number with the color of a point, but at an abstract level, they're doing the same thing. At an abstract level, they're doing the same thing. They're going from some thing in the data space, and we are mapping it to something in the kind of visual property. Horizontal and vertical position might make a lot of sense for numeric variables, but color works too. The shape of the size of the point also works, right? Some attributes only work with categorical variables, such as the shape of the point, whether you're going to use a triangle, circle, or square. That's got to be like a categorical thing. But if we're talking about the x or y position, that makes more sense for numeric things, but it could also work for categorical variables, which we saw, right? We could put brown hair at one position vertically, and black hair at another position vertically, and blonde hair at another position vertically. And so that's what we have, okay? So for things like bar graphs, if you think about the x-axis, the bar graph is often categorical. But if it's like a scatter plot, the x-axis will probably be numeric. Okay, so let me just show you what something might look like in base graphics. And before I forget, let me give you your second view quiz answer. Today's second view quiz answer is the letter E. E as in elephant. E as in elephant is your second view quiz answer. Okay, so the visualization that we produced could be created also with base graphics, but it's kind of a lot more work to do this, okay? So first you'd have to turn your, say the variable gender, categorical variable gender, into colors, all right? And with two colors or something, you could use if else. If you had more colors, you're gonna have to use a little bit more of a complicated statement, but it can be done. You can convert hair color into a vector of shapes. R uses PCH values, and we can do this. And we call plot. We have to create legends and stuff, and we can do it. And here's our plot. Okay, we have height on the x-axis, weight on the y-axis. We've got hair color and gender represented here. I don't know, has anyone tried to create a legend in R's base graphics? Okay, was it a fun process? Probably not, right? Like creating legends in R is notoriously tedious to do. Okay, it can be done, but it's it's tedious. So thankfully, when you just do it with ggplot, it does it for you automatically. It'll create these legends for you automatically, which is really nice, right? So this is kind of the same plot, just we just tell it how to map the attributes. Okay, let's revisit this thing, but we'll kind of start from quote unquote scratch. Okay, so again, here's my data frame, and with ggplot, it has to be tidy data. ggplot is part of the tidyverse, so it's expecting all of your data to be tidy. And you can call ggplot, and you give it the name of the data, right? So the data frame goes in as the first argument, which also sets ggplot to work nicely with pipes, right? So you could use dplyr to reshape, create new variables, or I guess tidyr would reshape the data. You use dplyr to create new variables and summarize and things like that. And then you can pipe it straight into ggplot, and whatever you've created will go into as the data argument. The first argument there is the data. So you can do that. And then the other argument is you have to provide the aesthetic mappings. And so here I'm going to just say map height to the x-axis, map the variable weight to the y-axis. And when I do this, it just creates an empty thing. And perhaps the first time you use ggplot, you might have created this and you might have gone, why isn't ggplot working? Why don't I see any dots, right? Because if you did something like this with plot and R, it would actually produce dots. And ggplot doesn't do this. And the problem here is that we haven't specified any geometric objects to represent our data. And ggplot doesn't know, do you want to use points to represent your data? Do you want to use lines to represent your data? How do you want to do this? It's not going to make that decision for us. So we have to specify what kind of geometric point to do, okay? So all we've done is we've given it the aesthetic mappings with AES, and we need to tell what geometric objects to put there. So here I'm going to do ggplot of our data, df, with this aesthetic mapping, add point geometric objects. And so it adds points for the each kind of row that shows up in our data. And this is what we get. All right. One thing is that when you create ggplot, you can actually kind of save some of these things into objects for reuse later. So I'm going to call ggplot, store it into this object p, and then I can do p plus geom underscore points. So this command here, this part I'm going to call p, and I'm going to just add geom points, so it's would be identical. And now I'm going to add another aesthetic mapping here. I'm going to say take the variable gender and map it to the aesthetic attribute color. And so it does that, okay? And so the color, we've got red and blue or teal or whatever color these things are, okay? So we have these colors represented here. There is, everything doesn't have to be an aesthetic mapping. You can also just have settings, okay? Settings specify, some visual property, but the key difference with settings is that they do not care what the data values are. So here I'm going to just say size is 10 and color is blue. So then every single dot becomes size 10, every single color is blue, and no property of the data is being conveyed by the size or color of the dot, okay? Is there anything, are we getting any information about the data by looking at the color of the dot? No, there's no information being conveyed because every dot has the same color. Every dot has the same size. So there's no information about the data being conveyed in this thing. And that's what a setting does. So a setting does things like, maybe you have a preference for a certain color or a preference for a certain thing, and that's fine, but it's not going to be conveying any information about the data itself because everything's going to have the same thing. You can change the scale. So again, the scale is how we go from the data to the visual attribute. if I go back a slide, ggplot determined the scale for us. It said, well, the smallest data value you have is 62, and the largest data value you have is like 72. So my scale on the left-hand side, I'm going to go just below 62, like maybe 59.5. And on the right-hand side, the edge, I'm going to go just a little bit above your maximum value, maybe to 72.5. And that's what it plots here. Okay. Now we could say, you know what? I don't want you to do that. I want to specify what my lower bound should be. I want to specify what my upper bound should be. So we are going to set the scale for the x-axis ourselves, and we're going to say the limits are going to be 60 and 100. And ggplot says, okay, lower bound 60, upper bound 100. Here you go. Here's the plot that you have asked for. Okay, and we might do this if we're expecting at some point values as high as 100. Okay, for height that doesn't really make sense because what? Someone who's 7 foot tall. I don't know who the tallest person ever is, but you don't really see people much taller than 7 feet, and so you probably don't ever need to go above 84, 85 inches or something like that. Okay. You can change other scales. So in our thing, we had color, and in our data set, as of now, we had two genders represented, and they were ggplot picked the default colors of, I don't know, that salmonish red color and some teal, turquoise, aquamarine, I don't know, something, right? And you could say, yeah, I want different colors, right? And there's like, R comes with its own set of named colors, and I think ggplot has named colors. You can just look up named colors in R, and you can specify, and here we got orange and forest green, and if you had more categories, you can specify, a whole vector of color names, and you can also use, what do you call them, hex codes, right, for the colors and stuff like that, so you can do that, okay? You can't really see on the projector because it's such a bright and powerful projector, which is great, but for subtle, the contrast is so high that you can't actually see the lines. But there's actually like a light gray tint here on my screen, but not on the projector. And then you can change kind of that background color from light gray to white. And theme VW makes the background white and adds gray lines, but those gray lines got washed out for the projector. If you download the file, you can actually see them. Okay, and there's a bunch of themes that you can do. Theme _ black and white, I think is one of my favorites. It's very simple. It's minimalistic, so I kind of like that. One thing is that when you call print, I need to talk faster. ggplot, by default, whenever you write something in R, it just prints it out. And if you're running a script and you produce a plot, and if you want the script to produce your plot, you have to call print on that plot itself. Okay. There are stats that can be calculated. So if you think about like making a histogram by hand, it's actually kind of a lot of work because you got to take your numeric data values and you got to bin them into like little categorical bins, and you got to create like a summary count, and then you turn that count into a plot in the histogram. And because it's such a common plot, ggplot will do that, has that created for us in geom_histogram. Okay. All right. So there are a ton of different geometries you can use in ggplot. And we've already seen the point geometry a bit, and I'll just show you the line and bar geometries very briefly here. But hopefully, by explaining kind of the grammar of graphics and this concept of mapping data values to visual properties, that will at least give you a framework for dealing with the other geometric objects. And so you can go to the ggplot reference, right? I think it's ggplot.tidyverse or something.org or something like that, and it has kind of all of these different reference values and things you can create. But here, let's just take a quick look. So here's kind of the reference thing, and here's the cheat sheet of all of the things you can do. Okay, bar graphs. So I'm going to just kind of blitz through this very quickly. And before I forget, let me give you your last view quiz answer. Last view quiz answer for today is D. D as in dog. D as in dog. Okay, so for bar graphs, here I've got this little table. I've got 3 groups: control, treatment 1, treatment 2, and then the values, 5.03, 4.66, and so on and so forth. And I want to create a bar where the height is this number, 5.03, 4.6, and stuff like that. So I'm going to call it geom_bar, and we're going to map the group onto the x-axis, the weight onto the y-axis. And when I call geom_bar, I want the height of the bar to actually be this value itself. So we're going to use stat equals identity. And when we do that, we see control is, 5 point something, treatment 1 is 4 point something, treatment 2 is a little bit higher than that, okay? Here's another data set. I've got cultivar, categorical variable, 2 cultivars, cultivar 39 and cultivar 52. Here we have dates, and we've got 3 dates. Day 16, day 20, day 21, okay? And then we've got weight, which is numeric, and so we're going to put date on the x-axis. So we've got 3 dates, so we're going to see 3 positions on the x-axis. I've got y on weight mapped to y, so the height of the bar will be y, and the fill color for the bars will be the cultivar. So we'll see 2 different colors here because I've got 2 cultivars, 39 and 52. And here to kind of make them side by side, we do position dodge and stat equals identity. And this is the plot that we get. 3 positions on the x-axis for the 3 different dates, 2 colors for the fill colors, 2 cultivars, and the height of the bar is the weight. The other variables, standard deviation, number, and SE, those were never mapped to anything, so they are not represented in our visualization. Here's just another thing. This is from the Diamonds data set. The Diamonds data set has something like 54,000 rows in it, 53,940 rows. And we're just going to look at one of the variables. We'll look at the cut of the diamond. And apparently, how the diamond gets cut is important for how it reflects light and stuff. And you've got different categories there. And so here, I'm just going to map cut to the x-axis, right? And the y-axis is going to kind of get figured out for us. When we do geom_bar, the behavior of geom_bar is to go through that variable, tally up how many times a certain category appears, and create a plot with that height. So we have ideal cut diamonds, and apparently that showed up, 20-something thousand times. And so that's what we have. The arrangement of bars here is in the order of the factor. This is an ordered factor. So it goes from kind of worst cut, which is fair, to the best quality, which is ideal. And so it arranges it in that order: fair, good, very good, premium, ideal. Here's another data set. This is, I think, looking at data from the 2000 census to the 2010 census. So it could be updated with 2020 census data, but this is. And so from the year 2000 to the year 2010, they looked at which states had changes in population, and Nevada, I don't know how you pronounce that state, had a huge change in population, grew by 35% over that course of 10 years, okay? And so here we're looking at that, and we're gonna kind of plot this. And so we're gonna take the abbreviation, okay, the 2-letter state abbreviation, put it on the x-axis. We'll map the change variable to the y-axis, and then the fill will be the region. And here we have either states in the south or states in the west. And this is what we have. The default behavior for arranging kind of character data is to put them in alphabetical order, okay? And so we have this. Here, I'm going to map the change variable to the fill color, okay? And so now I'm kind of double emphasizing the fill, and we've got Nevada with the biggest change, having the brightest color, and other states with less change, being colored a little bit darker. You could rearrange the bars. So here I've got X as reorder, We're going to reorder the abbreviation. So it's still abbreviations on the x-axis, but it's ordered by the change. So now they're in that order there. Okay. And again, here are just a few other things. Here I'm changing the color, the scale fill manual, and I tried to pick UCLA colors for this. You can change how the gradient looks. So the default is from like dark blue to bright blue. But here I said, on the low end we want red, and on the high end we want blue. And so it's supposed to be a gradient that goes from red to purple to blue. Okay. Line graphs, just very quickly. As far as line graphs, you can have, it looks a lot like a scatter plot, but they join in with lines. You can choose different colors for each line. That's an attribute. If you're printing something in black and white, and you can't show different colored lines, you can have different dotted lines, solid lines, dashed lines, things like that. We've seen a lot of scatter plots. You can change the points. You can change the size of the points, the color of the points, the shapes of the points. Again, shapes of the points, not very helpful. Colors of the points, something like that. All right, you're gonna have to look at the rest of the slides on your own time, but this is gonna be useful, plotting data from multiple data frames. So you might have different data sources and you wanna incorporate them in this same graph. You can do this, but you're gonna have to specify for each geometry, okay, where the data sets are coming from. So take a look at these examples here. Homework 4 has been posted. I know some of you guys are still finishing up on homework 3. But homework 4 has been posted, and it covers R6. And then homework 5 will be coming in the later days, and that will incorporate ggplot and other stuff we're doing. Okay, it's good to see you guys. Have a good rest of your day. Have a good weekend, and we will see you guys on Monday.